we are going to go ahead and look at trig integrals right now. And this first one is kind of a review of u substitution. So this could have been done with u substitution using calculus AB material, but or at least calculus AB techniques. So when I look at this one for u sub, I've got two options. I can either let u equal sine, or I can let u equal cosine. Now if I were to try and let u equal cosine, the derivative of cosine is negative sine, and for u sub you always want to cancel something out, but I look over here and that's sine cubed, so there's 3 sines there. So I can only cancel one of them out and I'd still be left with 2 of them. That's no good. If I let u equal sine, the derivative of that's cosine, I only have 1 cosine, that would be canceled. So I'm going to do this quickly here. So u equals sine x. So then I get the du is equal to cosine x dx. And I'm going to divide by cosine x to solve for dx. So we'll get du is equal to, du over cosine x is equal to dx. And if you're not sure of this u sub thing, you can check the video on u sub, and that will help refresh your memory. So then I'm going to go ahead and actually substitute it in here. So where I see sine, I'm going to replace it with u. So there's sine cubed, so I can write u cubed. I'll leave my cosine x there. Okay. Instead of dx, I will replace it with du over cosine x. Alright, and I'm going to go ahead and I'm going to cancel out both of these cosines here. That's what u sub does. U sub should always pretty much cancel something out, unless the derivative unit function is just a number, but I'm not dealing with that right now. So then I'm going to go ahead and all I have left is u to the third du. So I'll just go and find the antiderivative of that. It's u to the 4th over 4 plus c. And then I'm going to go ahead and I will plug my sine of x back in for u. So it's sine to the 4th of x over 4 plus c. It's not sine of 4x. Okay, so that was a little review. But it is important because the idea of using u sub to cancel things out is what we're going to use here. So the only thing I'm now going to change in this problem is I'm now going to add this a squared right there. So it's sine cubed x times cosine squared x. Now the problem here, if I were to try and do the same thing, let u equal sine, derivatives cosine, but notice I have now 2 cosines. So I'd only cancel one of them, it wouldn't work out. So, and same thing, again, if I let u equal cosine, it still wouldn't cancel the sines out when I found the derivative. So here's what I'm going to do. When you have something set up like this, where the exponents, are greater than 1, or at least, and both of the exponents are not 1, like the last one, this was an exponent of 1 last time, you're going to work with the odd one, if you have an odd one, okay, and you're going to split it up. So here's what I'm going to do. I'm going to do sine of x times sine squared x times cosine squared x dx. Okay, so notice how I split this up. It's the same thing, there's still 3 sines, but I just split it up. And what I'm going to do is I'm going to replace that with something using this trig identity. Sine squared x plus cosine squared x is equal to 1. Oops, it's cosine squared x. So that's a trig identity that you should have learned having your bag of tricks right there. And where I see sine squared x, I want to substitute in. So in order to do that, I'm going to solve here for sine squared x by subtracting cosine squared x from both sides. Okay. So since sine squared x is the same thing as 1 minus cosine squared x, I'm going to take 1 minus cosine squared x and substitute it in where I see sine squared x. So again, instead of writing sine squared x, I'm writing that 1 minus cosine squared x. Okay. So now what I've done is, notice now the sine only has an exponent of 1, and now I'm left with cosines as well. Okay. So at this point, now I can use u substitution. And the trick here is, which one do you choose? Do you let u equal sine or let u equal cosine? Well, think about it. If you let u equal sine, you take the derivative, it would be cosine. You wouldn't be able to cancel out either of those cosines, or all of those cosines. You'll be able to cancel out one of those, and that's it. If you let u equal cosine, the derivative is negative sine, you can cancel that one out. Okay? So let's see here. I'm going to let u equal cosine x. So then du is going to be negative sine x dx. And then I'll solve for dx, so I'll divide by negative sine x on both sides. And I've got that. So now I'm going to go ahead and I'm going to do my substitution. So my sine x I'll just leave there. So integral of sine x. Where I see cosine x, I'm going to substitute in a u. So it'll be 1 minus u squared. Again, where I see this cosine x, I also substitute in a u. So it'll be u squared. Where I see dx, I'll substitute in du over negative sine x. Alright. And as which usually happens with u sub, I've got these two things that cancel out, and that's good. Now I'm just left with u's. Now, at this point, I need to do some distributing, okay? I need to distribute this u squared to both of these. And I also have this negative, and I could do a couple things with it. I could bring the negative outside the integral and just leave it there till the end, or I could just distribute it in right now, and I'll go ahead and do that. So you can almost think of that as kind of like a negative u squared, because this negative is just multiplied times u squared. So when I distribute it times the 1, I will get negative u squared. When I distribute times this u squared, I will get plus u to the 4th. Okay. And then what I need to do, now I'm set up in a way that I can easily take the antiderivative. So I just go ahead and do the antiderivative, negative u cubed over 3 plus u to the 5th over 5 plus c. And my last step is I need to go ahead and plug back in my cosine x where I see u, because that's what I did my u substitution with. So it's going to be negative cosine cubed x over 3 plus cosine to the 5th x over 5 plus c. Alright, so that is, a trig integral problem here, and you can see it's not necessarily anything new that we're learning in Calc BC. It's just we're kind of using stuff that we already knew in a different way, I guess you could think about it. Alright, let's take a look here at another one. So this also works out real well if you only even have one thing here. So in the last case I had sine and I had cosine. In this case here I have cosine to the 5th, okay, of 3x, but no sine. But that's okay. It's still odd, so I'm still going to treat it the same way. When it's an odd, you split it up in the same way. Another difference though, it's to the 5th power. So since it's to the 5th power, I need to actually split this up 3 times. It would be cosine x times cosine squared 3x times cosine squared 3x. Okay, in the last case I only had to do that, I had 2 of them. In this case I need to split it up 3 times, but it still all adds up to cosine to the 5th. Oops, that should be 3x right there, I'm sorry. Okay, now, I'm going to go ahead and I'm going to use my trig identity. Now, the trig identity, has the same rules when you have something else besides x in it. So, meaning, this is still true, sine squared 3x plus cosine squared 3x is equal to 1. So I can minus sine squared 3x for both sides to solve for cosine. Okay? And what I'll do is I'll now plug in 1 minus sine squared 3x in where I see cosine squared in both places. So cosine 3x times 1 minus sine squared of 3x times 1 minus sine squared 3x dx. Alright, at this point, I've got a cosine that only has an exponent of 1. That's awesome. Now I have to think, okay, it's u sub time. What do I choose for u? Well, should I choose cosine? I know that derivative will go to sine, but look at all the signs I have. I can't cancel all those. If I should let u equal sine, that's a good thing, because there's only one cosine to cancel. So I'll let u equal sine of 3x. So the derivative of that, sine is cosine. I have to use my chain rule, so I have to multiply by the derivative of my inner function, which is 3 cosine 3x dx divide by this, so I get du over 3 cosine 3x equals dx. Now I'll go ahead and do some substituting. So to the integral of, the cosine will stay the same. Where I see my sine squareds, I'm going to put in a u for sine, which will make it u squared. So it'll be 1 minus u squared times 1 minus u squared. And then it'll be du, so instead of dx, it's this guy, du over 3 cosine 3x. Okay, so now I'm going to go ahead and I'm going to cancel out my cosine 3x's, which is a good thing. This over 3, I'm going to bring that outside the integral as a 1/3. Okay, not deal with it now. I'm going to distribute these out, so it'll be 1 minus 2u squared plus u to the 4th. And I'm ready to take the antiderivative. So the 1/3 I'm just going to put here, keep in parentheses, outside these parentheses. Antiderivative of 1 is u. Common mistake is people will put x, but this determines what your variable will be, du. So if it was d theta, we change the theta, and so forth. So this should really be u minus 2u cubed over 3 plus u to the 5th over 5 plus c. And my last step is I just need to go ahead and plug back in my u. So it's going to be 1/3 times sine 3x minus 2 times sine cubed 3x. 3, kind of an extra set of parentheses I didn't need there. And then sine the 5th of 3x over 5 plus c. So again, let me just read this out for you because it might be hard to read. 1/3 sine of 3x minus 2/3 sine cubed of 3x plus a 5th sine to the 5th of 3x plus c. Apologize for the sloppy writing. Just trying to fit it all in here. But yeah, so that's some trig integrals right there.